Hi, in this video, we are going to talk about get item or underscore get item in the linked list. So as you are very familiar with already in Python list, we can, do the bracket and then give it an index and that to be able to retrieve a single item from the list. So let me run that, and obviously, when we retrieve item number one and index one, sorry, the item at index 1 is 202. And now, as it turns out, this bracket thing is nothing more than yet another synthetic sugar for something that is called the get item. And I can give it the index, again, I here, and these two are exactly the same. Okay, so here I get, the same item twice. So what this means is that we can actually, for our linked list implementation, we can also support the bracket operation. So let me turn back there. So we can implement the underscore get item. Now, the first thing I want to do when this method is called is I actually do want to validate index, because there can be a number of things that can go wrong with the index. So I'm going to validate the index. And what kind of thing do I want to check with index? Well, to start with, I want to make sure that the index is an integer. So I want to check the type index. If it's not an integer, then I raise a type error. Let's say index should be int. Now I can actually, for Python list, the index doesn't have to be an integer. It actually can be a slice. Well, that is something too complicated for us to support here, so I'm just going to support integer. Okay, so another thing I want to make sure is that if it's not a negative number, or if it's some index that is out of bound. So I'm going to say if index is less than 0 or index is greater than. Now, what is the largest index it can be? It's the size. Well, actually, it's size -1, right? If it's the index is the size, it's already out of bound. So, yeah, and if either of these cases are true, I'm going to raise a value error. I'm going to say the index is invalid. So I could obviously implement negative index as a Python list. Again, that's a little too complicated. Or and for if the index is bigger than size, I could probably say something like index out of bounds error rather than a value error. But it's just a design choice. It's okay either way. Anyway, so after I validate the index, now what I'm going to do, what you probably usually will do, is you actually say, for I in the range of, I guess, size. Yeah, but and then we're going to walk through the tree, right? But since we've already written the dunder iter, I really want to use that again. So I am going to just say for d in self. Now, how do I find the index though, right? We are not looking for a particular piece of data. We are given an index that could be 0. 0 means the first item, the first data in the list, and 1 means the second, so on and so forth. So I really want an index to compare with the given index. So for that, there's actually something, if you don't know already, there's something called enumerate. So I'm just going to enumerate self. So what enumerate returns, in addition to the data itself, it actually returns an index. It starts at 0 conveniently. and then 0, 1, 2, and 3, and so forth. And it returns the index with the data in a tuple. So the first in the tuple is the index, second in the tuple is data. So I'm able to do this. So I can just say if I is the index, then I'm done. I'm returning the data. And that's it. I'm done. So okay, now that I've done this, okay, let me make sure. Yes, and then we should test this, right? So I'm going to come back here. I'm going to write the test. So what the test is doing, again, I have a list of data that I'm going to insert into our linked list, and I'm going to actually check, if I want to get LL, the linked list 0, I'm going to get 1, I'm going to get 202, 2, I'm going to get 33, etc., etc. Right? So I am actually going to write a loop, and again, I am going to use enumerate, but remember we're adding to the head, so the what's in my linked list is going to be the reverse of this list of data. So I'm going to have to reverse the list of data, and I'm going to enumerate over them, so I get an index 0, and then the item itself, the item in the reverse L is basically just 5, 64, 33, and so on. Okay, now I'm going to assert the item. So this is what I'm expecting from the expected value from this list, right? And I'm going to compare the expected to what I'm going to retrieve from my linked list using the index. So hopefully if I wrote the get item correctly, this will run. And yes, it did. Okay. Now, another thing we have to make sure is that if the index is something bad, then we get the appropriate exception raised. So here is another test case for get item failures. I'm going to have the same setup, and then we're going to try to use a string, let's say a string as an index, which is we expect it to raise a type error. And if we say something like a -1, we should get a value error. If we give it the size again, remember that is not a valid index, and that should also raise a value error. All right, so let's run this test, and yes, it also works. So that's good. Now, one thing I would just want to point out, even though get implemented under get item allow us to use the bracket notation, it does not mean that we can use the bracket notation on the left-hand side of an assignment operator. Okay, so if we actually run something like set item, we would use the bracket operator, but on the left-hand side of the assignment, we're going to get an exception. It says it doesn't allow us to assign things to the item. Now, in order to make this to work, you have to implement, surprise, surprise, set item. Right? That's the setter for item as opposed to get item, which is a getter for the item. And here's the documentation for that, and there are plenty of resources online helping you to implement that if you need it. I'm not going to go over that right here, but it could be good for you to try to implement this yourself. And if you do, make sure you test it.